So this is where we left off the other day. The last thing we did was powers to powers is multiplying, and I gave that like backwards PEMDAS way to memorize it, or to just think about what happens if you write it out. And it turns out it's the same thing if you're dividing to a power, because I mean, what happens if you have like the reason you can like throw that squared into both is a over b squared would be over b times itself, right? So you'd get a times a, or a squared, all over b times b, which is b squared, and that works for any power. So you can throw that power into there if you're dividing a fraction as well. So simplify negative 2 over y to the fifth. That's going to be negative 2 to the fifth all over y to the fifth. Right. 2 to the fifth, we're going to get negative, I think that's 32. Right. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Yep. And then here, power to a power, x to the fifth to the third is going to be what? Multiply them, x to the 15th. And then 3 to the third is going to be 27. 3 times 3 is 9, times 3 is 27. Okay. Anything to the 0 power is 1. It makes complete sense. Well, let's think about this. Like 2 to the fourth is 2 times 2 times 2 times 2. 2 to the third is 2 times 2 times 2. 2 squared is 2 times 2. 2 to the first is 2. 2 to the 0. What have we done every time? We've divided by 2 every time, right? By 2, by 2. When we divide 2 by 2, we get anything to the 0 is 1. So if you did it with 3s, you would divide by 3 every time, and then your end one would be 1. So that's why anything to the 0 is 1. It's just following a pattern. So again, you just have to be extra careful of where your exponents actually are. 3 times x to the 0, x to the 0 is 1. 3 times 1 is just 3. Now this whole thing, now it's the whole thing, 3x to the 0 is just going to be 1, because anything to the 0 is 1. And since it's this whole chunk to the 0, the whole thing is 1. This is important. Okay, now to what we were supposed to end off with. Okay, so simplifying expressions, these are the requirements, but it's kind of intuitive. Basically, condense and simplify as much things as you can. That means reducing fractions, whether it means with variables or with numbers, right? No parentheses, no powers to powers. Basically, just do everything you can. I don't think we need to write those down. I don't care about that. Okay, so simplify this thing to its entirety. I'm probably going to do the exponents first here. So 20x cubed divided by, guys, what's 5x squared to the third? 5x squared to the third. Close. Be 5 to the third times x to the 6th, right? That third goes to both. 5 to the third, 5 times 5 is, So 125 x to the 6th. Power goes to both, and then power to power, you multiply. 2 times 3 is 6. 20 is 5 times 4. And 125 is 5 times 25. 5s are going to cancel. 3 x's here cancel with 3 x's here. How many are going to be left in the bottom? 3. So our end result is 4. That's all that's left up here. It's kind of messy. 4. What's left in the bottom is 25 x to the 3rd. I'm waiting. All right, 10x to the negative 3, negative 2 times x to the negative 3 to the 3rd. I'm going to do exponents, I'm going to do the exponents first again. Negative 2 times x to the negative 3rd to the 3rd is going to be x to the exponents to exponents. We multiply. Negative 9. All right, exponents to exponents, x to the negative 3rd to the 3rd, multiply them. X to the negative 9. Negative exponents means flip, throw that in the bottom, make it positive, throw the other one on the top, make it positive. So really I'm going to get 10x to the positive 9 when I flip that one up. On the bottom is still negative 2x to the 3. 10 divided by negative 2 is negative 5. So there's 5 left. 3 of the x's here cancel with 3 of them there. How many are left? 6. And then technically division by 1 is just itself. Oh, hey, real quick. 4 divided by 4 is what? 1. So when you cancel, when we're talking division, it's really like 1 over 1, right? There's always 1s left when you cancel. I just thought I'd throw that out there because canceling in division is not like canceling in addition and subtraction, because canceling in addition and subtraction leads to 0. But in division, canceling is 1. All right, what does negative 2x to the 3rd to the 4th turn into? What's negative 2 to the 4th? 16? Positive 16 or negative 16? Positive 16, because this negative 2 is in these parentheses, so when you times negative by itself 4 times, you're going to get positive. And then x to the what? 12 all over 5x to the negative 1st. So we have to kick that x up. It's just gonna, that's like if we kick this up here, it'd be times x. So x to the 12 times x will be x to the 13th all over 5. So another important thing, if you kick an x down, or if you kick a variable down or back up, it's multiplying on top or bottom, so you can combine them, right? So if I have like x to the negative 5th and x to the 4th, that's really 1 over x to the 9th, because I'd kick the 5 down, 4 and 5. Okay. Oh. 5x to the 5th y squared. Everything gets squared. Are we okay? 5 squared is x to the 5th squared is y squared squared. Um, 20 over 25, that simplifies to 1 over 4, so we could just write the 4 in the bottom. Wait. Why am I like crazy right now? 4/5. 4/5. Right, they both divide by 5. 2 of the x's here cancel with 2 here, and I'm left with 8 in the bottom. This y gets kicked down, so I have how many y's in the bottom? Good. Sorry, going fast. I don't know anymore. Good. Yeah. Yeah. I guess. Maybe. I don't know. I don't know what you're trying to tell me. So we have -3 x to the 3rd to the -5th. Is it really x to the what? X to the 3rd to the -5th. X to the 3rd to the -5th. Powers to powers, you multiply. What's 3 times -5? Uh, 3 divided by 6 is just going to leave 2 in the bottom. Kick the y up and kick the x down, and it should be negative. All right, -3/6. One more. Okay, we have this whole chunk to the -1st, which means that whole chunk needs to get thrown up there. So x to the 4th, y to the -1st, or -4th. There's actually multiple ways to do this one. Well, that's the way I'll do it. Or you could do the powers to powers first and multiply. Whatever you want to do. And then that would technically be to the 1st. Anything to the 1st is itself. I threw this whole chunk. This whole chunk is to the -1st, so I threw it up top to the 1st. What? Yeah. I mean, the other way to do it is you powers to powers, you multiply, and we get -2 x to the -4th, y to the 4th in the bottom, right? And then you have to kick the x up. So this way, we're just putting this thing on top and then kicking the y down. 5x to the 4th times x to the 4th is going to give me 5x to the what? We have x to the 4th times x to the 4th. What does that give me? 8. Remember, kind of like reverse PEMDAS. If we're multiplying, we're really adding. Right? Powers to powers, you multiply. Multiplying, you're adding. Because this is x times 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 x. You'll have 8 of them. That y gets kicked to the bottom.